I've installed this PCB here, and it's working at the moment. You can also observe that the outdoor unit is functioning perfectly. However, the indicator light is blinking very rapidly. Normally, when there's no error code, this light blinks at a slower pace. Besides, I'll show you on the indoor unit's display. Here, you can see the E1 error code appearing. I'm going to explain in detail why this E1 error appears on units of this model. Now, let me explain the possible reasons behind this E1 error and how you can fix it. When we discuss the E1 error code, first, I'll cover the outdoor circuit and then the indoor circuit, along with all potential faults. For the outdoor circuit, if it's completely dead, right now you can see the light is blinking, but if there's no blinking at all, even though electricity is reaching it and it doesn't turn on, this means it's likely damaged. In such a case, the E1 error will show on the indoor display because there will be no communication between the indoor and outdoor units, indicating a serial communication fault. Another possible reason for this error could be that even though the PCB is powering on and everything seems to be working perfectly, if we look closely, this section here is known as the communication area. If components like the optocouplers, diodes, or resistors in this section become faulty, it can still cause the error to appear. The unit may turn on, but it won't function properly, leading to the E1 error due to lack of communication. Now, to further explore the causes of the E1 error, I've placed another PCB here to make the explanation clearer. This will help me illustrate more about these issues for you. Here, you can see the cooling plate or heatsink on top of this PCB. In the other PCB, there's no heatsink because I've removed its IPM, Intelligent Power Module. When the IPM is shorted, the entire PCB often stops working, which can also trigger the E1 error. This particular PCB was showing the E1 error for this reason. Another common cause of the E1 error in these types of PCBs is due to capacitors. Often, capacitors become shorted. Here, we have a 450 volts, 470 microfarad capacitor. If we look at the specifications on the other PCB, there's a slight difference even though both PCBs are quite similar. This one has a 450 volts, 680 microfarad capacitor installed. If these capacitors swell, that can also lead to an error. This area should receive around 320 volts DC. If it doesn't, the rest of the PCB might work fine, but the microcontroller will misinterpret the signals. The SMPS, switched mode power supply, will produce all the low voltages, but due to faulty main voltage, there will be improper communication between the IPM and the microcontroller. This could lead to a short circuit, causing the E1 error. Similarly, I have removed the PTC sensor from this circuit board. In the other PCB, as you can see, the PTC sensor, which is the orange-colored component, is present. If this PTC sensor goes bad, it can also trigger the E1 error, especially if it blasts. In such cases, the unit will fail to function properly. The PTC sensor plays a crucial role when electricity enters the unit. Its main responsibility is to allow the voltages to pass through and turn the entire unit on. Once everything starts functioning, the switching relay is activated, and the load from the PTC sensor is shifted to the relay. This ensures that once the compressor starts, the load is no longer on the PTC sensor, but is transferred to the relay, allowing smooth and soft operation of the system. In addition to that, let me now explain the possible faults in the indoor unit. So, if the PCB is working and you're getting the E1 error, it means the PCB is functioning fine. However, the issue here is that the indoor unit also has a communication system. You can see here that this circuit, and especially the area around the optocouplers and their associated resistors, are responsible for the communication system. These components help the indoor unit communicate with the outdoor unit. If this communication system malfunctions, it can cause issues. However, the chances of this happening are quite low. If the system fails, that's when you could encounter problems, but generally, these issues are rare. The PCB has been in several workshops for a while, trying to get fixed, but it hasn't been repaired properly. Even though the outdoor PCB is working fine and the indoor PCB is also functioning well, the issue lies somewhere else, since the system is still showing errors. Now, what could be the possible fault here? It seems that a mistake was made. I'm not sure when or by whom, but something went wrong. If we look closely, there's an issue with the wiring. The line, neutral, and signal wires are not connected properly. The main electricity supply is directly coming in, but the wiring seems to have been set up incorrectly. In this case, the main supply comes to the indoor unit first, and then through a switching relay, the supply is sent to the outdoor unit. Here's what happened. The main supply is correctly positioned, so when you turn on the PCB, power goes into the PCB, and it functions perfectly without showing any errors. However, the issue arises with the output supply wiring. The red wire here, labeled as 1L, is supposed to supply power to the outdoor unit, and the neutral is directly connected to the neutral terminal. The yellow wire is used for the signal. However, they mistakenly swapped these two wires, which has been causing the unit to malfunction for a long time. Because of this reversed wiring, the system has not been able to function properly, despite the main components being in working order. When this PCB came to me, I first checked the outdoor unit directly, and it was turning on. I also verified the voltages, which were all correct. Afterward, I opened up the indoor unit, thinking there might be a fault in it. As soon as I opened it, I noticed that the wires were swapped. This wiring mistake was the cause of all the issues here. Now, I'll fix these connections and show you how correcting the wires will fully resolve the E1 error. As you can see, I've now properly connected the wires. I'll turn on the unit and let's observe what happens. I've connected the main power supply and I'm switching it on now. You can see the switching process and the outdoor PCB has also started working. When I turned it on, it started working at 17 degrees. Within a few seconds, both the fan and compressor started running. Since the piping isn't connected yet, we won't run it for too long, so we'll turn it off shortly. But as you can see, the unit is now completely repaired and is functioning perfectly. Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.